Lab 2, Dipole Magnetic Fields. In this experiment, I measured the magnetic field of a dipole magnet using a magnetometer application on my phone. To do this, I first calculated the magnetic moment of my magnet and used this with a program to calculate magnetic field, as well as recording the net magnetic field at a given distance from the magnetometer using the application. To ensure accurate measurements, I first had to align my phone to compensate for the Earth's magnetic field. To do this, I slowly rotated the magnetometer until the X component of the net magnetic recording read 0. Once the magnetometer had been aligned, comparison of the net magnetic field reading to the magnetic field of Earth at my location, which in Atlanta is 48.6 microteslas, allowed me to confirm the positioning of my magnetometer. To find the distance dependency of the magnetic field, I recorded the distances at which the magnetic field X component would read 20, 70, 120, 170, and 220 microteslas. Using this data, I created a logarithmic plot of the distance from the magnetometer versus the X component of the net magnetic field. With this data and the trend line for the plot, I was able to find the intercept to determine the magnetic moment of my magnet to be negative 8.98. To measure the magnetic field off of the main axis, I first moved the magnet a distance away from the magnetometer to where the net magnetic field would read 100 microteslas. This was roughly 7 centimeters. Once this was done, I recorded the Y and Z values of the magnetic field for later calculation. My next step was to move the magnetometer upwards the same distance in which I moved the magnet to create a 45-degree angle between the magnetometer and the magnet. Once this was done, I measured the X, Y, and Z components at this location of the net magnetic field and adjusted the Y and Z components with the values recorded earlier. Doing this, I was able to get the net magnetic field to be 8.5 times 10 to the negative 4. For comparison, using this function in GlowScript code, I was able to simulate a magnetic field with the same value of magnetic moment recorded previously and got 5.08 times 10 to the negative 4. Since my simulated magnetic field was 5.08 times 10 to the negative 4 and the calculated magnetic field was 8.5 times 10 to the negative 4, some differences arise. I think that these differences are from the surroundings of when I was performing this experiment and minor objects that may have interfered with the magnetic field. What if no compensation for magnetic north? If this experiment had been performed without first aligning the magnetometer to compensate for Earth's magnetic field, I think that all measurements would be skewed by the presence of the field. Most likely, the readings for the X component of the magnetic field would be disproportionate to the Y and Z components, increasing overall magnitude. What if two magnets? If the experiment was performed with two connected magnets instead of one, I think that the field on either end of the connected magnets would be similar to that of one magnet, but the two poles which are connected in the middle would change the field closer to the center of the magnet, as well as increase the overall strength of the field.